Now, what happens if the number in front of x squared is not 1? Well, if the number in front of x squared is not 1, our diamond method goes out the window. And what we're going to do is we're going to use pure guess and check. So I'll make 2 parentheses. And I'm going to say, what multiplies to 7? Well, I'm going to go x and 7x. What multiplies to 4? I'll go 1 and I'll go 4. Now, let me check. So I'm going to distribute. I'm going to take x times 7x. Well, that's 7x squared. X times 4 is 4x. 7 times 1 is 7x. And 1 times 4 is 4. Notice I get 7x squared plus 11x plus 4. This does not check. So I don't use that one. First thing I'm going to do, I'm going to flip them around. I'm going to go x plus 1. And, whoops, not x plus 1. That'll be the same exact thing. I'll go x plus 4 and 7x plus 1. So once again, if I take x times x 7x, I get 7x squared. If I take x times 1, I get x. If I take 4 times 7x, I get 28x. And 4 times 1 is 4. So you get 7x squared plus 29x plus 4. Notice that one checks, doesn't it? That gives me my correct answer. So my answer then is 7x squared plus 28x plus 4. Now, you can always guess and check. But guess and check gets to be kind of monotonous. If you have some small numbers, guessing and check always works. There is a factoring method. There's a strategy we can use. It's a British method, is what it is. It's called factoring by grouping. So what we're going to do is we're going to force this into a group of 4. So, oops, I don't know what I did there. I just want to erase this because I want to start over with you. Okay, delete. There we go. Now, here are the steps. They're on the previous page of your seminar. What you're going to do is you're going to take your trinomial. The first thing you're going to do is you're going to multiply the first and last terms. So I'm going to take 5 times 6 on this problem, 5x squared minus 13x plus 6. That's where I'm going to make my diamond. So I need 2 numbers that multiply to 30, but now they add to negative 13. Then what I do is I rewrite this polynomial. Instead of writing negative 13x, I'm going to say, well, geez, what multiplies to 30 and adds to negative 13? Well, it'll be negative 10 and negative 3. So I rewrite that polynomial with 5x squared minus 10x minus 3x. If I have a positive and a negative, I suggest you write the negative first. If you have 2 negatives like we do here, it doesn't matter. Then we're going to factor it by grouping. Look at the first 2 terms. What goes in that? In this case, it would be 5x. What goes in the next 2 terms? Well, that would be negative 3 because my leading coefficient is negative. I notice that x minus 2 is the same. So I factor that x minus 2 out, and I get x minus 2 times 5x minus 3. Let's use that same method with this problem. So I've got 7x squared plus 29x plus 4. So what I'm going to do is I'm going to multiply my first and last terms. 7 times 4 is 28. And I want 2 numbers that multiply to 29. Well, that would be 1 and 28, or 28 and 1. I don't care which way you do it. I'll go 28 and 1. So now, instead of writing 29x, I'm going to write it as 28x plus 1. So I get 7x squared plus 28x plus 1x plus 4. Then I look at my first 2 terms. What goes into 7x squared and 28x? Well, that's 7x and x plus 4. If I look at my next 2 terms, what goes into both x and 4? Well, the only thing that goes into both x and 4 is 1. So I'm going to go x plus 4. I notice the x plus 4s are the same. So I get x plus 4 times 7x plus 1. So the only time I'm going to guess and check is if my terms are prime. That is, my first term is a prime number and my last term is a prime number. If I have anything else that's not prime, I'm going to use this method because I think this will be shorter in the long run. So let's take a look at example 6. First thing I notice 5 is a prime number, but 9 isn't. So I'm going to use the British method. I'm going to take 5 times negative 9. That's negative 45. I want two numbers that multiply to negative 45, but they add to 12. So I start thinking, 1 and 45, that's definitely not going to work, is it? And then 2 doesn't go into 45. 3 goes into 4. Oh, 3 and 15. And I want the bigger number to be positive, so I'll say negative 3. This is where if you write a negative and a positive, write the negative first. So I'm going to rewrite this as 5x squared minus 3x plus 15x minus 9. Now I'll factor it by grouping, 2 at a time. The only thing that goes into 5x squared and 3x is x. So I get 5x minus 3 plus what goes in both 15 and 9, well, that'll be 3, 5x minus 3. So we can factor out the 5x minus 3. So I'm going to factor out that parenthesis, so I have 5x minus 3. What's left over is x plus 3. And there you have it. Let's try another one here. Let's take a look at the third one. Notice on this one, something goes in all three of them. Do that first. So I notice 3 goes into both of these. I'm going to factor that 3 out right away. So then I get 3 times x squared plus 5x plus 6. Now we're going to factor the parentheses. But notice there's no number. Your coefficient in front of x squared is 1. So now you can use your diamond method again. I need two numbers that multiply to 6 and add to 5. Well, that 2 and 3 then, right? 2 times 3 is 6, and 2 plus 3 is 5. So the 3 stays out. My first parenthesis is x plus 2. My second parenthesis is x plus 3. Always look for the common factor. What we did in the previous lesson does not go away, just because we have some more complex ones with these trinomials. If we take a look at example 8 here, and the first thing I notice, 3 is prime, but 20 isn't. So 3 times 20, well, that's 60. And it has to multiply to add to negative 17. So I want a negative and a positive again. And actually has to multiply to a positive 60. So I want two negatives, don't I? So I start going through my list. So 1 and 60. Negative 1 and negative 60. That doesn't work. 2 and 35. That's 37. That doesn't work. 3 and 20. That's negative 23. I'm getting closer. 4 and what? Let me see here. Oh, 4 doesn't go into 60, does it? Wow. I just noticed I made a mistake. It was 2 and 30 up here. So it'll be 4 and 15. Well, that's negative 19. That's not going to work. Okay, 5 and 12. There we go. Negative 5 and negative 12 gives me negative 17. So I'm going to rewrite my problem. I had to do a bunch of guessing and checking on this one, didn't I? So imagine how many times you would have to guess and check if you did this just by pure brute force. So we're going to go 3x squared minus 5x minus 12x plus 20. And then I'm going to factor by grouping. What goes in my first two terms? Well, x. And I got 3x minus 5. My next two terms, I notice my leading coefficient is negative. I'm going to factor in a negative. What goes in both 12 and 20? Well, 4 does. So I get positive 3x minus 5. Oh, look at that. My parentheses are the same. So 3x minus 5 times x minus 4. And there you have it.